Welcome guys, Flutter Atlanta. To anybody tuning in online, welcome. Just so you guys know, the mics we're using are in the ceiling and they can hear pretty much everything. So if you're messing with anything, just know that they'll be able to hear it online. Don't say anything you'd regret. My name is Emmett. I'm the Flutter team lead at Black Airplane. I have a background in native Android and iOS development. I've been using Flutter for over 2 years now, probably close to 3 years, and we've published well over 7 different Flutter apps at this point, and I love Flutter so much that I'm also using it for my own startup. I want to give a quick thank you to Black Airplane for letting us use the space and also the food and beer. Black Airplane is a leading development agency in the Southeast, and we have a special team that produces top quality work, and we're pretty much capable of building anything. So today we're going to be talking about state management, but before we get into it, Flutter has just released Flutter 3, so I thought we would kind of recap what's new with Flutter 3. So we're just going to go hit the main bullet points in this article real quick. So now they have released stable Linux and macOS builds. So basically this has been in beta for a long time, but now from one code base with Flutter, you can build for Android, iOS, web, Windows, macOS, and Linux. So you're on 6 platforms now. Embeddable systems, I think is what they call it, is in beta, and when they say that, the biggest application I've seen is like your little Google Home hubs. So just know you're about to be able to build stuff for that in Flutter as well. A whole bunch of different little types of menus to make the UI feel normal on those new added platforms. International text input, accessibility, all sorts of different performance updates. They've added foldable phone support. This was pretty exciting because a lot of this code was introduced from Microsoft. So Microsoft has kind of picked up Flutter and is also using it for app development, and they've been contributing towards that since they're building foldable phones now. Variable refresh rate support, simplified releases, pretty standard updates here. Big web updates, image decoding. This is going to be a big deal if you're trying to load a whole gallery of images or have a lot of GIFs. Different web app lifecycle stuff, so you can finally add yourself a splash screen on Flutter. You don't have something just kind of white until your app loads. And then you can do a plain HTML interactive landing page before your Flutter app loads all the way if you just want to make things quick and responsive. All kinds of different housekeeping linting updates and a whole list of performance improvements that they continue to build on. Different updates for ads, support for Material 3, which is Flutter's primary UI kit. Continue, and I'm not sure if it's listed here. They also have officially a game development toolkit. So if you're into game development, they have a whole physics engine, 2D rendering system, so you can go make a game, which is pretty exciting because you can make a game once, release it, web, Android, iOS, all the platforms, so that's pretty cool. All right, so back to our state management presentation. So why do we need state management? This is basically to simplify handling the state of multiple elements and how they interact with each other. It'll also help with separation of the UI and business logic, and it normally will increase your ease of testing due to that separation. So how do you choose? This is one of the biggest debates in Flutter right now. Today I'm going to talk about 3 different state managements and show you some code examples and what they look like to implement. But there's probably over 100 different state management options at this point. The best way to choose is to just explore and find which one you enjoy the most, because at the end of the day, they all accomplish the same goal. So the state managements we're going to look at today are going to be block, getX or get, depending on which branding you know, and then Riverpod. So these are 3 of the most popular, which is why I have chosen these. And this was my first experience with Riverpod. We do a lot here with both block and getX. So if you see any of my Riverpod code and you're like, oh my gosh, you did it wrong, I'll link my repository and you guys can update it if you'd like. So let's hop on over. So I did a very simple code example, and I'll run you through what this kind of looks like. And again, you'll notice that each instance of this application on the left here is going to look exactly the same. And that's on purpose. It's to show you all of these accomplish the same thing, just in different ways. So the first one we're going to view as block. So basically what I have here, you're just listing out a couple of products. When you add things to the cart, you'll see that this cart number updates here. Kind of hard to see on the screen, but it tells you how many items are in the cart. And then you can click on these and it will actually persist the state of the cart and what's in here and also the count here. So you can remove or add these here and it will persist across the screens. I did this as the example because I wanted to show you in a little bit more complex of a project on how you would need to persist state over multiple screens and multiple widgets with all of these so that you had a little bit more exposure to what it would be like in real life. So this is going to look exactly the same for all three of these. This is the getX example. Notice they're all pretty much exactly the same responsive-wise. They all feel exactly the same. The performance is negligible in our eyes. If you wanted to get nitty-gritty, I'm not going to today. You can bring up your performance and frame by frame, see if any of these would perform better. Something about Git or getX, it gets a lot of hate. You'll see a lot of hate online. There's a lot of people that swear by it and a lot of people that hate it. The reason why is getX has a lot more in it than just state management. So they have routing, they have easier ways to show scaffolds, they have all kinds of widgets that come out of the box with getX. So with that being said, a lot of people hate it because they figure you're learning getX and you're not learning Flutter. In this example, we're only using the Git state management, so if you want to compare state managements one-to-one, just know we're only looking at that today. We're not using any of getX routing or anything like that. So let's first hop into the code. So head over to my file structure over here and kind of give you guys an idea of what's going on. I have a widgets folder, which is just going to have the reusable product tile widget that I was using everywhere, which is an example of separating your business logic from your UI code. And then we have both the block folder, Git folder, and Riverpod folder, as well as a data folder. This data folder is really just a mock API service that's just going to symbolize that quick loading that you saw at the beginning, just to make it act a little bit more real time. And you could see that all of these showed a loading state before loading in the data. The models, we use Freezed, which helps generate some code here. But basically, it's a very simple class that's just going to have an ID, a title, and a price, which is what you saw getting displayed there. So let's hop into block first. So block, it has the most files. And they've actually improved on this significantly. So normally when you have a block, you're going to have the actual block itself where your business logic is contained, and then you'll have another file holding all of the events and another event holding, or another class holding all of the states. So the way block works is you're going to send your block an event. It's going to use the business logic to decide what happens and then send out a state. This is a little bit different than how something like getX works, which we'll see in a second. But as you can see here, there is a lot of files generated, and one of the biggest hate factors of block is that there's just so much boilerplate code. When you want to generate one piece of state, you have to generate 3 files, all the different classes to represent everything, and it can get bulky very fast. But it is very robust and it's very straightforward to test, and it's used by a lot of really, really large Flutter teams for this reason. It doesn't give you a lot of weird flexibility. You're not going to get into weird situations because you have to declare every event and you have to declare every state, so you're not going to ever have any sort of weird situation with it. But again, you'll just create this event here, and then you'll see if you go into the block itself, you basically just say when the loading event is called, then, or when the add product is called, then go add this to the cart. We also have another state or another block here. This is related to actually loading the products from the API, and one of them is the cart. So all of these have different ways that you inject these dependencies into the application. So get, you're going to put controllers. Providers are initialized as global variables, which is going to be for Riverpod. And then block has what they call a block provider, or in this case, a multi-block provider. So it's going to look up the tree to try and figure out where this is at and make sure it has access to it. So all of these have dependency management. Right now in this example, all of these are just declared right at the beginning, not doing any sort of dynamic to try and keep these as comparable as possible. So actually in the screen, now that you have all your business logic and state management set up, what does it look like on the UI side? Basically, wherever you want the UI to rebuild based on a state change, you're going to wrap the widget in a builder, and then you can determine what state is come out of the block, and then it will rebuild just that UI. So it's going to force you to pick the different parts of your user interface that need to rebuild on certain changes, which is going to keep your UI rebuilds really performant. It's not going to rebuild large chunks of your UI that it doesn't need to, which really helps with frame rate and performance. So you'll see here, you do have this big block builder method. This isn't something that's uncommon. It's very common syntax with like a list view builder or something like that, so it's pretty normal. And you're going to still use normal stateless widgets and stateful widgets along the way, so there's nothing weird or custom about your UI elements in this sense. The same goes for this, the listing screen. You'll see we have a block builder around that icon button in the top right, and then we actually also have a block builder around the body, which is where we'd actually be listing these out here. So we rebuild this whole list view anytime new products get loaded, and it will refresh this screen. So that is block in a nutshell. And remember, block is basically events go in, the business logic decides what happens, and then states come out. So next up, let's look at get. So get is more of a reactive state management system. So basically, whenever you change a variable, it's just going to update the UI where the variable is using. You can see how this could be very user-friendly. It's very quick to type and iterate, but you're going to lose some of the readability. So in programming, typically you have a trade-off between readability and writability. Normally programming languages that are very easy to write are not very easy to read. So if I were to just give you code that was very easy for me to write, you would have trouble because you have to decipher what is this variable, what does this mean, whereas very verbose code, which is what block is kind of representing, is going to be very easy for you to kind of grasp on right away and everything that's happening. So again, we have two different controllers, a cart controller and a products controller, and you can see there's a lot less boilerplate. For these controllers, we don't have multiple files, it's all happening in one place, but we do have special types of classes, and we do have special types of variables. So Rx is going to represent a reactive variable, and they have custom things built out for maps and list that helps check for the equality there when it changes. And it's very simple. These are normal methods here on when you're actually going in and changing this. So in this sense, it's very light and it's very easy to understand on this on the per file basis. So the products controller is very simple as well. We just have an on init that calls the load, and then we're good to go. If you wanted to have a separate load method so you could call it over and over, you could very easily do that as well. You'll see this is just an Rx list of products, and it's just empty at the beginning. When we look in the screens here to see how we actually interact with this state, we also have a new class called a get view. What a get view is it's just a stateless widget, but it allows us to have shorthand for accessing whatever controller we specify here. Instead of saying get.find controller, whichever controller you're looking for. I'll show you an example here. Get.find. So here you'll see get.find controller of the cart controller, and then we can access whatever in that controller. When you have a controller specified here, you can just type controller dot and it will just assume that. So that's the advantage, gives you a little bit of shorthand there. But otherwise, you have to access controller by doing that get.find. This can get kind of verbose and ugly actually in the UI code, which isn't fantastic, but you do make up for it with these OBX builders. So this is the get's version of the block builder. So whatever is in this is going to change whenever a variable is that's accessed in here changes. So this is where the readability gets a little challenging. Figuring out when all of this code rebuilds, you're going to have to figure out all of the different reactive variables from the controller that are in here. And it's going to rebuild every single time one of those changes. So this could get less performant in the sense if you're updating a whole bunch of these variables not at the same time, you're going to trigger unnecessary reads or unnecessary refreshes. But they do have a more specific version of OBX where you can specify specifically what variables if you want to. OBX is just a very easy way to just, all right, throw it in there, whatever I'm going to throw in while I'm writing, I'll know it's going to update whenever it changes on the controller side. So you can see the attractiveness of GetX because it's very simple to write and it's very simple to learn. But you're going to lose all of the verboseness again of block and the readability, and also it does get a little bit more challenging to test. They have a specific testing mode and there's kind of different things you have to do there, but the business logic is still very isolatable in these methods, so you can write normal unit tests for stuff like that fairly easily. So let's head into Riverpod, and again, this was my first experience with Riverpod, so if you're watching this and you are a Riverpod lover, I may have done things not in the ideal way. So you're going to see how I implemented things here just by reading the documentation and following generally the same pattern as the other state management. So instead of controllers and instead of blocks, they have what they call providers. So you're basically going to create a normal class here that has a state notifier, and this is going to notify whenever anything in this value, in this case a list, changes. So again, you're going to have your normal simple methods just like in the GetX controller with the add product and the remove product. The only thing that I ran into that was a big problem for me with Riverpod is they did not have good support for things like lists and maps. You'll see me doing weird things here, setting state equal to and then using spread operators instead of just saying, hey, let's just add a product to this list. And that's because out of the box, the list comparable does not check all of the contents to see if it's equal or not. So it just assumes it's still the same list and the contents are the same. So it wasn't rebuilding my user interface until I can trigger a whole new list is equal to this. So that was a big knock for me for Riverpod. But other than that, it's actually fairly clean and the organization is fairly simple. Like I said, you declare these kind of global variables here. And then you can access those from your UI. So the UI digging in here, you're going to use ref.watch. So they also have a custom class called a consumer widget, which is their version, I guess, of the get view. But when you have this, all of your build methods now have this widget ref. And this ref variable is what's actually going to allow you to access those providers. So that is going to say whenever something in this provider changes, we're going to rebuild this user interface. So it actually ends up being not too verbose in the UI side, which is fantastic because once you have this variable here, you can just say cart is empty, cart is blah, 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 just like you normally would without having to worry about some complex state management. You don't have to check what the state is. You don't have to access the state once you have it here. So it's actually fairly clean on the UI side. So yeah, Riverpod, fairly clean as long as you have good ways of storing where your notifiers are and all of that. Again, this will be fairly simple on the testing side. The only thing confusing about me for the docs was they had a ton of different types of notifiers. So this is a state notifier. They have one that's has like more built out for classes or more built out for just straight up values like normal raw values. So yeah, their docs were a little bit confusing coming from the other state managements for me, but that's probably just because I don't have enough experience with Riverpod in particular. So that is basically the demo, and I just want to recap that no matter which of these you choose, at the end of the day you got the same outcome, barring some minor performance changes depending on how well you outline when your UI actually rebuilds. Before we move on to anything else, do you guys have any questions? Or if anyone online, if you have any questions, feel free to type them in chat. I know that was a lot, so.
So what do you use primarily?
So on my startup, I'm using Get and GetX. I'm actually using a lot more than just the state management. I really enjoy the routing package and some of the other things that I get with it. We have a whole bunch of apps here, and we've had a lot of block apps and a lot of GetX apps. So we pretty much used either block or Get. Most of the guys seem to like Git because it's easier to wrap your head around early on. But again, Git gets a bad rap, so we need to make sure we know what we're doing with the other ones as well. Block has gotten significantly better. In this demo, this was Block 8. It used to have even more boilerplate code, but now it uses a package called Freezed for code generation that helps limit how much you have to actually manually type out to set up the block.
Now that you've actually walked through Riverpod, do you see yourself ever implementing it in your daily job?
Probably not. We're so familiar now with Git and Block, and again, they all produce the same result. If anything, I would lean more into Block because from what I've seen, the job market is demanding Block the most. That seems to be the most industry standard. So, and from a learning perspective, you're going to learn everything about Flutter the right way when you go with Block. A lot of people are starting to hire based on which state management you like the most. Like I said, GetX gets a bad rap, and a lot of overseas developers use it as well. So they're starting to, from what I've seen, discriminate and say, we only want people that use Block. Our project uses Block. I haven't come across anybody that says we only use Riverpod. So it would probably be between Block and Git for me. Do you have clients that specify the state management used? At Black Airplane, we typically don't. If they came to us with a pre-existing application, we would use whatever state management they already had. But a lot of the clients that we have at Black Airplane come to us with an idea and just say they want it built. They could care less about the state management. In fact, normally it's more of a conversation between native Android, native iOS, React Native, or Flutter. Very rarely would we ever get to a conversation where they're picky about the state management. Well, if nobody's got anything else, I'm gonna go ahead and wrap up here. So next time we're gonna walk through push notifications. Basically, we'll talk about an entire push notification system. We'll be sending the push notifications from Firebase, and we'll also show you how to actually keep records of the notifications in an application, so that way you'd have more of a complete notification system for your apps in the future. Thank everybody for coming out, and everybody that tuned in online. We'll see you.